Hello, Tomáš is here and we are doing another programming drill. Now we have examination period and I have checked some of failed works from practical part of the exam. And actually I noticed that you need more practice. You need more drill. This part of the exam is the crucial one. Theoretical is not that hard to make it, but this one it's kind of crucial here. So you need to practice more, and I've prepared for this some endorsing materials. I will do 3 episodes of the drills. It will be focusing on the fundamentals of 3 separated topics. First topic is the array drill, and we will do some algorithms basically by using arrays and these things. Then we will do a drill for strings, and the last one will be for linked list related task and these things. I am also preparing last one bonus drill, and this one will be just if you are wondering what was my preparation for this practical part of the examination PA1, what I have made before I made it. So but for practicing, I think better are these drills that I'm doing right now. Okay, so I think let's start. This is the array drills, and the first thing that we should do some input generator for that. We will have here some couple of tasks for arrays, and it would be nice having some data to run these algorithms on, and also for some debugging, for some checking and these things. So definitely do not be lazy and make some input generator. So let's do some generators, CPP, right? I'm using CPP because I want to be able to use like Boolean data type, true and false, and by the way, on the proc test, whole semester was compiling proc test CPP, C++ compiler, so it's nothing new for us. Okay, so let's include stdio, let's include stdlit here, will be of use, in main. I think today we will need bash command line arguments. I will just write this, what you probably argc, like arguments counts, and rgv, arguments array. This is what you probably have seen somewhere. You can write on here, and 0. So we will go through these later. And now I want some configuration of my input generator. So I will need seed for a random number generator to initialize some starting state. I will need n, which is like number of numbers. By the way, I can also set some values here. It's like number of numbers I want to generate. I will have like minimum, let's do like 0, and maximum, let's do like 100 here. This will be my configuration, and now let's do some algorithm to generate them, if we can call this algorithm. So int I is probably going from 0 until n, is plus, and number will be, yeah. And now I need some generator. So let's use like man srand, which is, and the generator has two parts. Srand is the function where we can put the seed to initialize random number generator, and then we have rand function, which is a function which is giving us the random numbers basically. Here you can see some possible implementation. Here is basically some global variable which is having this state. It can be rewritten here, and this random number generator is not that great. This is something that definitely shouldn't be used for generating like the password or certificates for server and these things. But for our purpose, it's more than enough. Yeah. So let's use here srand to initialize the seed, and number will be basically minimum plus random number, and we'll do here the modulus maximum minus minimum. Oops. Yeah. So this will be our number. So minimum is the minimum thing here, and maximum right now it is unreachable. Yeah, it's unreachable, so it can be maximum -1 in this case. If I want to include a maximum, I could do like +1. I think I like the fact that it's unreachable maximum in this way. So let's do it in this. Let's keep it like this. And we will just print the number on separate line. Yeah, so like this. Let's test it for this configuration. Generator -0 again. Again. Yeah, and now it will give us always the same because we set up the seed here. Sometimes people are initialized by current timestamp this, so it looks then like they have different, but I will keep it this way. And yeah, I want just to be able to set up this configuration as dash line arguments, right? So I would like to write like seed here, n here, and some minimum and maximum here. So this would be like, this is what I want to do. I can get these values from these inputs from these arguments into my main function. This is just how many arguments I have, and this is basically these literals, and it's starting with this one, actually how the program was called. So this will be always the binary of the program. Yeah, so let's do it. So if rgc, so first I will check how many arguments I have, and if I have enough, it's good. So if I have enough, so like 1, 2, 3, 4, 5. So if I have 5, it's okay. I also want here some boolean to show like usage error. So usage error is false, and I want here like if usage error, then I want here like printf, and here like usage. Again, I can actually use the first argument, right? Here and here it's seed. This is the numbers, like size maybe. Come on, size, yeah, good. Minimum and maximum. Can I do this? Yeah, good. Added 0. Yeah, so we have usage error and we are still missing to set up this configuration, but I will once again compile. So now it's usage error, but I want here return. It's actually error state. Yeah, now we have usage error. If we do this, see numbers minimum maximum. Yeah, so let's do this. So yeah, okay. We can use scanf. It's the same function as scanf, but it's scanning from some source, so from some string. So in this case, I will use here the argv1, which is the argument I am expecting this seed. He is this seed, and this will be like the input of scanf. This is the format, and then it's the same as always. So when this fails, and this isn't, then usage error is true, and yes, so I think we are done here. So let's compile generator. Then we change the seed. This looks good. This looks good. Yeah. Yeah. So I think we are done with the generator. We may also do these like optional arguments. I think like optional things are written like this. So we want at least like generator seed and size, and here just like if it's more than so now these things should be like option. Is it? Oh, I have to recompile. Yeah, so now we have this. Like this, and you can still set it. Yeah, good. Okay, so let's generate some input, like 10 from 0, oh my god, from 0 to 2000. Let's generate and let's make some file. No, it's input. I'm doing. Let's generate also some higher input. Yeah. So we have two inputs here, 10 numbers and 100 numbers, and I think we can be happy with this. We have input generator, and let's move on the task. And now input generator, I will include it somewhere in GitLab or somewhere, or maybe let's put it on GitLab. So give me a sec. I will initialize the repo. Yeah, so here we go. Here's a drill. So we can use our generator here, and you can make it with me. Yeah, there is also our task list. Where is it? Right. So so we have here now tasks. I think this is okay that we did it like together. But this one, these tasks you should do on your own, and I will be just presenting these tasks, and when I present, you should try your own try. You should give it a shot and make it. Then you can watch like my approach here, and after, when you see like a gap between like your approach and my approach, between like your efficiency and my efficiency, then try to make it again after you see me. And so this is where you actually getting better. When you remake the thing in a better way, this develops your approach, and you really need this. You really need this to get better in things. So yeah, does this work? Does it work? Yeah, good. Yeah. So okay. So first are really easy. Then I think from here it will be a bit more interesting. But yeah, make it all, make everything. So let's do first one is to make input generator. Yeah, so first one is done basically. So first one now is that we will find the minimum and maximum in the array. I know yeah, this is really simple, but still let's do it. Min and max, maybe just make just task 1 C E. Yeah. So this one is very simple. We can do it directly from the input actually, but I think it's not the point. We have we have practicing, and I think it will be better for us if we actually wake up like to put every single number into the array. We don't know how many numbers we have in the beginning, so we have to use like resizable array here technique. And so yeah, so let's recap this technique. I know it can be done without storing the array here, but let's do it. So we array, let's call array, and I don't have any other name than numbers here, so I will stick with this one. And size, it's obviously 0. Oh, it's obviously 0. And in capacity, it's 0 at this point. I set up this to the null here. So I have to be careful. Now I have only empty array, not initialized Okay, so processing the input until the end of the input, it can be done by while loop. So we are making while loop until it's successful. So scanf %d. I will need some another variable here, like some number. Until it's successful, we are going, and on the end, if there is still something which, if there isn't like end of the input, then basically there have to be some garbage which we couldn't use. So if there is something on the input still, std in is input here, printf, and this is invalid input. I'm not gonna be elaborate more in invalid input, but basically program should do nothing here, so return and some error state like 0. Yeah, this is not my type style. Okay. And number, I need this variable, and yeah, so we have to do here like classical, what we always do, a classical resizable array. So we want to put something in the array. We firstly ask if there is enough space. So if there is more, or if there isn't, we have to fix it. You know, I usually was typing in like capacity times 2, but now we starting from 0. So we have to be careful here. Capacity times 2, like 0 times 2 is still 0, right? So I'm just adding here 1. And yeah, so let's do numbers. Yes. Then we cast the realloc into data type we have here, right? So realloc, here we will put the old address, and when it's null, realloc can also work as a malloc here, so it's not a problem. So numbers, and here a new size, which is like there's a capacity times and size of one element of the array, which is size of, let's do like numbers 0. Usually we can write it in this way, or this way is the same. I will do this way. Yeah, what is the problem here? I need to the lib. Okay, what I should never forgot is like to free the thing. So here should be like free numbers, and also in this case, just to be correct. Okay, so after this if check in this code, we know that we have enough capacity because it could be before, it could be there from before, or we improved that. And so let's just add into there. So numbers, size, always size is the writing index, and number. And now here we are just doing the algorithm, it's not task. So minimum and maximum from the array. Yeah. And maximum, I like having these functions. So when a is smaller than b, we just return the a otherwise b. So we are just, this returns just smaller of those two arguments, and max and similar this one. So we will need obviously to go through the array and maximize the maximum and minimize the minimum. And we should initialize this. I could use like int max here and int max or int minimum for the maximum, but let's do it this way. Let's use, for instance, first element of the array. It's also nice initialization, but careful here. Before we access the first element, which is exactly here, we should also check if size is at least 1. So if size is smaller or equal 0, this is basically, there is basically nothing to do, so invalid input since it's not input at all. Let's put some another, yeah, and now we can do it. Now we are happy. So since we have having like first elements in maximum already, we can start from 1 here, and we can write like minimum is min of minimum and numbers I, and similarly for maximum. Does this work? Seems this works. Yeah, good. Okay, and let's print some output. So minimum is %d line, and maximum is %d line. Minimum, maximum, yeah. Yeah, we have actually alias, right? So let's compile task 1. Let's run it, and let's put the input. Let's get the input. So yeah, 95 is obviously correct, and this looks, yeah, it looks great. Yeah, there is nothing to screw up, I think. This one was easy just to heat her up. So let's do task 2, and I will use this code as the boilerplate for another task, because this part is basically what we would do like always. So let's keep it, and we are here should reverse the array. Yeah, so let's try reverse the array on your own, and just stop the video and let's try it. And if you feel that you have it, you can watch mine, or you can skip this if you are successful. If you're not curious, whatever. Okay, so to reverse the array, yeah, let's do it. You don't need this anymore. Okay, so let's do, yeah, so we can do like for int and doing it like this, for size divided by 2, but like going like this way, and then you have to like think about some stuff. And this is the approach that I would probably not use here, but I will just show it. So we would here just trying to swap this one and this one. So just like the pseudocode numbers, and here like size -1 minus I, and yeah, then yeah. So this is like the possible approach, but I will show you another approach here. Yeah, by going until the beginning of the array, I think like the more like fault resistant approach here is to make like index for beginning and index for end of the array, and just using these and swapping on these indexes, shifting these together and checking when program should end like naturally. So let's do it in this way. Like begin from 0, and would be like size -1, and we can do like while begin is smaller than n. This is obviously the ending condition here, and we can do like int then. So let's back up begin, for instance, numbers begin. Let's do like numbers begin. Come on, is numbers end. That was kind of risky here. Numbers and now will be like template, temporary. Sorry. Yeah, and this should be it. So let's check it out. Print it. We want to print the array, so we need some loop. Size I plus, and let's go. Printf %d space and numbers on index I. New line on the end would be nice, right? So let's have it, and yeah, I think this should be good. So let's check it out. gxx task 2. Okay. So yeah, of course. Yeah, so my program got stuck out, and it's probably just because I forgot to change the state here, so it got stuck in this thing. It's kind of embarrassing, but I have to fix this. So let's move begin forward, and let's move end backwards, and now it should be it. I like this is the type of the error that you can make very easily. So it's always good. Yeah, it's always good to fix that. Yeah, you can also like test it that we will like we can run it twice, and we should have like original order here. So yeah, this is good. I like it. Okay, so that's the first task. Let's move on. So second one, yeah, we can read from here. The arrays are compared to arrays. Okay, so let's do it. There is not much specified here, like how we should compare So we will just check whether arrays are equal, so like all elements are equal and order is equal, so in this way. Yeah, so let's do it. Or maybe we can split this into two variants, like A exactly same and B consists of same elements, so like this. Okay, so let's make some input for that. Yeah, so let's do like, this is size 10, so let's do like input for task 3. Let's input 3 txt, and we will create input 3 txt as from 10. Then we will generate, so I want here like 10 elements. Then we will generate an array. Let's use a seed 10. Let's use 10 elements from 0 to 1000. Input 3. So this is one array. And maybe let's make a space here, and then let's make another. Yeah, so this will be same array. We made same field, and let's do another one. This is input 3 and dash 1. So let's generate here with another seed dash 1. Yeah. So dash 1 would be like same array, and dash 2 would be like different. Oh, sorry. I swapped that. Dash 1 are two different arrays, and dash 3 will be the same array twice here. Okay, so let's enhance our program here. So task, we will use again code from previous task and change it. So here I have numbers is not a good name anymore, so let's do like array 1. Let's make for these variables prefixes here. Array 1 size, array 1 capacity, and we will need also like array 2. Number is good. Let's not repeating this code here, so let's make a function, because this will be here twice now. We don't need to scanning under the end of the array, so let's do something like what we can do here, like read array. Yeah, let's do it. Read array. I think it's good. And we actually don't need here the resizable array because we have the sizes on the beginning. Yeah, so let's remove this. Okay, so let's do it this way. So read array, and we want here pointer to the size, so we can change size inside. So like size, and we actually don't need like capacity anymore. And let's do here like let's do it. So so if scanf and size is already pointer here, so we are not passing an address as when it's just an integer, but now it's pointer. So we doing just this, like these data types have to match all the time. So let's do it in this way. So scanf when it's not one, we print that. So let's do like return now here. We don't have to handle our output here. Yeah, so we have size. So here we do like we can also check like if size. You have to the reference if we want to access the value. So when size is small equals 0, it's actually unuseful size. So it's another thing, another reason to interrupt here. Yeah, and now just start array. So we can allocate malloc, and it's like the size of array times size. Maybe it can be for you sometimes like difficult when when you're using variables like this. So now we have like this size now is pointer, and as you can see I have like the tendency to put here a size instead of the reference, and it can be actually helpful if we use some prefix like p to know this is pointer. So now we have like in our name we have p size, and it's better for our brain that we see different name and we can associate another different word for this different thing. Okay, so here we do like size times smaller than size, and we want scanf %d. Okay, and here we can do like traditional way like this, and address of it. This is legit. I of course I will wrap it into here into the some if check, and we will solve an error. Yeah, but what I wanted to point here is that we can use this syntax. So this is just syntax to access the element of the array, and this is address of it. We can use also what C programmer would do, and it's like this, because we can have just a pointer and we can shift it by this offset, and it's also the address of if element here. So this this is how C programmer would do it, but for you, you can just stick with the basics. How you want it. So in case that we were scammed and there isn't enough numbers to make this input, we will just free the array and we will return null. Otherwise, this is already scanning into the array. Array is pre-allocated, so just return array, and then we are good here. So we can write here like we don't need these capacities. Also, this one is not necessarily. So let's do here array one is, and here we have read array, and here we put array one. Oh, an address like this. Yeah, good. This is good if array is null. So if not array, like this, then it's invalid input. Yeah, nothing here. Return 0 or 1. And yeah, let's do the same thing for another array. Array 2 size. If we don't receive array 2, we should now remove array 1, because array 1 was successful. So array 1, we free array 1 and we print out invalid input and return some error code here. Yeah. So, and finally we are doing the task. So task is to compare two arrays. So firstly, let's do it in like Sieve. Maybe I would do a function for that. So it's not like everything in the main function all the time. So let's do like bool arrays for R, arrays same, and there we go. Like yeah. So in array 1. So this is some simple program. When we have some problem here, some mismatch, we can actually immediately return false, otherwise we return true on the end. and nothing of this happens. Okay, so yeah, so we have two arrays. We shouldn't forget to remove them. So let's do like free array 1. Same for array 2. Return 0. And yeah, now let's do this stuff. So if our arrays same, and let's do array 1. We can actually do like identical and some new line here. Arrays are not identical. Print. Oh, I have typo. Print. Good. So let's do it. Yeah, so gxx task 3, we compile, and now we have input 3 -1. This should be, wow, it's invalid input. Okay, let's see. Oh, where is it? This is invalid input. Okay, so let's check it out. And now we are actually doing some debugging. We have some wrong thing here. So we are debugging. So invalid input, and I don't know which one it was, because I have here one invalid input, here a second invalid input. Yeah, so how to do debugging? Yeah, basically we have like two options. We can like printing out some things, or we can, in this point, it's not a runtime error, so we can also like using the debugger here like this, then run and debug, and I have to set up it. So it's like run and debug. This one gcc g++ built-in active file. Yeah, it's my newest G++. Yeah. Yeah, but this debugger, it doesn't have attached input. So to set up the debugger, here's a file launch.json, and here is like, here have to be like program, it's like file, it's like how it compiles. Here should be yeah, and here is command to run a program. Here you can put here some input. input 3-1.txt, and now if we make it again, our program will be working under this. So let's, so let's run it again. Let's save launch.json. Let's run it again. Arrays. Okay, so we made it wrong. Environment, external console. Arguments. So let's put it as the arguments. Probably it doesn't look like this. So this is the command, and these are the arguments. And I will put it like this, like with this redirection, and also with the file name here, and hopefully this will do it task free. And let's debug. Let's end this task and let's debug. So, and we have null here. So let's so we have to go again. We have to go inside. So to step inside, step into is F11, and F10 is just step. So we have size as a 10. This is weird. Oh, probably condition here. Oh, do you see that condition? I'm really that stupid. So it's not one, of course. That was so embarrassing, right? But at least we managed some debugging here. Yeah, so I think we don't need a debugger anymore. So let's end this and let's continue with our comfortable setup with command line these things. So yeah, task free. Let's do it. So G6 task free, compile, and we have try input 3-1 again. The arrays are not identical, and 2 arrays are identical. Yeah, so this is probably these first are not identical and seconds are good. Okay, let's do here different task when having like consist of same elements. So like all elements like are in the same like in the same number of times and these things, right? Yeah, to make it like naively it would be not, it would be, I wouldn't like it. Like, naive solution here is probably the worst, because naive solution here is that we should like pick an element from one array, compute how many times we have it in the first array, and then compute how many times we have it in the second array, and then like check it whether these matches, and moving like this until processing the full array, which is bad. So let's sort it. When we sort it, like, then actually we can use like previous technique. If we sort both arrays, then we can use like previous technique. So let's do it. Let's add two sorts and we will have a happy day. Yeah. So qsort. Okay, so to make qsort, yeah, I don't even have to like opening the manual. This is nice hint. So this is the address of the resource, a number of members, the size of one element, and comparison function. Okay, so let's do it. So it's array 1. Number of elements is size 1. Size of one element is of course size of array 1, like this, and of course comparison function. So it's function which returns integer. It's pointer to function const void, and we have here like as arguments to the function or parameters. As parameters to the function, we have pointers to two arrays, two elements. And here like int, so not int compare. Int compare would be good. So let's define int compare. Int compare int. Maybe follow the rule pointer, so let's do this. Yeah, so let's do this way. So when it's smaller than I swapped that. Usually it should be like this for increasing, so not decreasing array output. Yeah. So let's try to recompile, and also let's sort another array, which is array 2. Yeah, good. Arrays are identical, and these are not identical. Let's take this and let's shuffle it a bit. Yeah. Now let's try it again. This is number 2. are identical. Yeah, so this seems it works. Okay, list all prime numbers below number n. Yeah. So this is basically, we have two approaches here. We can do like a naive solution, just check one number whether it's prime number or not, or we can do like a sieve of Eratosthenes here. So we have like two variants here. I think we can do both. It's not a problem. Task for .cpp, and yeah, let's do it. I will also take some code from the beginning here, but it will not help me much here, to be honest. I will keep these functions, I like these, but yeah, it's not gonna help much. Okay, so naive solution here would be like, let's have some n as a, and so percentage d, come on, percentage d, address of n when it's not equal to 1, we know that this is bad. Turn else. Otherwise we are happy. So here we can do like for int I goes from 2 is smaller equal to n I plus, can do here like if is prime, then we print. Can do it. So let's do it. Can do it like this, for instance. And new line. So we are stacking these on the same lines. And this is the naive solution. Is prime can be like, so this one is solution n times, and here's like square root of n would be, and I have to make is prime in the square root of n for this. So let's do like naive. Let's do like, yeah. So let's maybe customize this a bit. Void task for naive, so it's clear, and we will pass here n. So it will be this. And then we also need like is prime in time of square root of n. So we have just some number. The worst thing we can do is like counting from 1 until n and checking if we have just two divisors. It's like the worst. We will use the advantage that if some number has the divisor, there have to be some other number. When we can multiply these together, it will give us like another number. So basically, when we have some number and we know that b is the divisor, then there have to be like some a or something, some another number, and together it will be a. So one of those two numbers have to be smaller, actually, or it's like a square root. So it can be like a times a, and then number is like or like square number, sorry, square number, of course. Yeah, so we will use this. We will go just from 2 until square root of n. So we can use it like if a in can compute a square root here and doing something. And I goes from 2 smaller equal, because we have to be careful. Squared prime numbers and it's plus. And if here we have a divisor, we can immediately say that it's not prime number. So if number times I turn true. So this is the algorithm. Math.h, and yeah. This is the naive way, and so task for naive n. Current day 50, for instance. Yeah, so this works. Let's do now something more serious. I hope it's right. Task for weather. And here you go. We will do Sieve of Eratosthenes. So what we will need is like the array of booleans, and we will set everything like it is a prime number, and Sieve of Eratosthenes will just setting these like back to not prime numbers, all multipliers. So let's do it in so let's do some array here. And I will use character. Character is just 1 byte size, and I need just boolean, but I don't have like just 1 bit data type here. I could use also, like if I want to use a memory like very efficiently, I could use like integers, for instance, and using every bit. So like using the integer, like unsigned integer, as 32 bits, and it would be the best use of memory. But let's use this. Use the char here. So yeah, so prime, and let's do block And let's do here, like n will be another here because of, but I need n plus 1. If I don't want to shift indexes, and the size of one character is Panos, but I'm still using this habit, like size of prime, like here. And by the way, this is not accessing of the first element of the array. We are just asking the size here. To compile is just founding here, adjust this number, the size of that. Yeah, of course. Am I stupid or what? Yeah. Okay, so now we can use like memset or whatever. And memset is a function which maybe just it would be better to show it. So we will put here like some resource, how we want to initialize every byte and number of elements. And it will set us the memory here. So let's set up like the whole prime number, prime buffer, then value, which is 1, and here basically the size of the array, which is this one. Let's do it. And for memset, what we need to include string.h. String.h. Good. So let's go. Let's do now Sieve of Eratosthenes. So we're going from 2, because 2 is the first prime number. We are going until n. Like this. Oh, actually, this doesn't matter. And so if prime, so if it's prime number on the index, and we will do now for j goes from I plus I times 2. J smaller equal to n, and we are going by i's, so multiples of I. I could also use here like from 2 until, yeah, like going from 2 by 1 until like I times j. It could be written a different way also, but I choose this one. So let's do it. So prime j, and on these indexes we will turn these false. Yeah, and that's it. That should be that. So So here, instead of is prime, you will just access the array prime. Yeah. Let's do 50. And we have same result. Oof. I'm thinking if I want to like compare speeds here, maybe it could be like nice it could be like nice demonstration. We can like measure the performance of our program. We can do something like let's we can use the system to measure. It's not like measuring of the performance of the program is kind of problematic, but yeah, when we have like two obviously different algorithms, I think we may found some differences here, but one of the problem here is that it's printing too much, maybe. No, it's not that bad actually. It's not that bad. So let's compile now the naive solution and let's measure. So we will use like time command, and we will use task 4. Come on, task it's like 8 out. And let's create some input here. Or maybe can we put input like this? I think we can, right? So let's do like a million. Maybe 10 million would be better. Let's see. Yeah, of course. Oof. Yeah, the output is so let's deny the output. Can you do like this? I think time uses error output, but I'm not sure. That's kind of weird. This is normal output of of the program. I don't know why we have this. Probably that. Let's maybe make input file task 4 0 Yeah, so now it measures and yeah, it's like 90 milliseconds. Let's make 10 million. 10 million, and yeah, it's 2 seconds. let's do. So now let's try this solution, and also we forgot here to free the resource, which we shouldn't do. Free. Fine. Let's recompile. Yeah, I'll uncomment this. Yeah, this is significantly faster. Very significantly. Because logarithm of 10 million is like, I don't know, like 13 or something like that. Logarithm of million is 20, sort of. If of 1000 million it's like 40, at least. But square root of million is 1000, right? So these are significant differences here, especially when we are having like a large input. Yeah, so I hope this was also interesting from this way, that you see some results of measurements and these things. Okay, so now here is another task. Compute greatest common divisor. Should be divisor, right? I think. Maybe both are correct, I'm not sure. I haven't math in English, so it's a kind of problem. Yeah, so compute greatest common divisor for array. Yeah, so this is another task, and maybe you will need some time to think here, because you know it's not that obvious. We obviously know like GCD for for two elements, for two numbers, but now it's for a whole array, so it's kind of a bit different maybe. So yeah, so feel free to pause the video and try to figure it out, try to implement, and yeah, and now I work. Yeah. So I hope you managed it, and yeah. So we will start with GCD between two numbers, and basically I think like there's if we want like GCD between three numbers, like GCD between like A, B, and C, it is just like a GCD and it's basically the GCD of A, B, and C. Yeah. So you can first like compute the GCD between those two numbers, and yeah, it will be the greatest common divisor between those two, and then we just can do it like this, right? We can just check this result against C, and it should be greatest common divisor between those three. So I think this observation is nothing that should be like explained like in deep. I think we don't need any like a math proof for that. I hope we just kind of understand this. Okay, so this is the math task. Yeah, numbers are actually, yeah, let's use some long here. I like sometimes like type def long ll, so I can use like ll instead of long. It's like just type aliasing, and now I am about to implement GCD algorithm for two things, which is well-known algorithm, probably the first algorithm we have ever done, GCD, and yeah. long A, long B. And I like here the recursive way to make things. So it's like if B is 0, we return A. And otherwise return GCD, and we put it here. Oh, yeah. I think this is the trick, right? So in case that A is a greater number here, we are just modeling it, and this will keep the continuation here. If A is greater, then next time it will be also a greater number, because this will be like here is where we actually like reducing the data. And in case that like B is greater, after run this operation, it will just swap number, and then it's like the same story as A is smaller than B. So I think this should be that. Yeah, if you're not sure, just test it. So we can we can every time write like GCD test, and we can test it if we're not sure. So we can like write a couple of asserts, and we can write like, yeah, so just GCD, and let's do like 3 times 7 times 5, and here like 3 times 5 times 11, and this should be like 3 times 7. We can use this some like 2 prime numbers, but 1 always. We can use like running out of the ideas. Times, I don't know, 31. Oh, yeah, but these numbers are same. Times 2. I think something like this may do. So let's do it this way. Let's do it. Let's test it as this. What I need here. Yeah, I'm having asserts. STD lib maybe still enough. I don't know. STD lib. Let's try STD lib. Whether I have assert. Plus 5. No, I need assert.h. By the way, but okay. Okay, then nothing. But what compiler was hinting me was assert for C++. So Of course this is wrong. Oh my god. Of course. That should be 3, 5. Yeah, good. Yeah, so I think we may be confident now, at least. Yeah, we may be confident with this implementation. But if you're not, it's really good to testing these sub problems, sub functions, basically, so you can know that you can actually use them and in way when you are debugging something huge, then there is problem if you have some minor pieces and you don't know if you can trust them or not. So it's very crucial here is to debug also some subunits of your programs, so you know that this unit is working. I can like build under that some other thing, right? Okay, so task 5 now it should be the array and should compute the GCD for that. So let's take some code here from this task, for instance, where we were just reading the array. Yeah, this is really good. So let's use it. Return. Let's do here return task 5. I could do it in the main actually. This is embarrassing. But maybe, you know what, just let's put this into the main function. So in the main function we have array. What's the problem here? Come on, it's the okay. It's the IO. Such a fundamental. And here we will call task 5 and we will put here the array. So int size. It's numbers and size. Three numbers, 0. Yeah, I think we good. So let's make here task 5. Come on, task 5. So to compute this GCD, I just need, it's something like a maximum was before, so I just need like some mid result. And I may use like array 1, like the first element of the array. And I think I'm pretty sure if I have this first element of the array, it's also the greatest common divisor. So I like the idea that even for the one element array, this works. So yeah, mid result. And let's process the array. So for int I, let's go from 1 I smaller than size, I plus. Let's do here mid result is GCD mid result and array I. Yeah, that's good. Yeah, I think this is enough. Maybe just return some integer here, and can just pick the number here, and or maybe let's print it here. There it is. Yeah, I think that's enough. So as you can see, it was very easy, very easy. I just made this and this. Let's see let's see some results also. So task 5, like this. There it becomes like 10 elements input. What's the problem? Yeah, okay, input underscore 10 dot txt. Get input and so probably here some numbers, prime number, or it basically doesn't have some common divisor. Yeah, let's maybe try some another input. Let's try something like 50, 100, 150, 200, and 25. Yeah, this is looking good. I like it. Here it's from Divisor 25. Yeah. Okay. Yeah, so we have next task. Yeah, I will have a little bit pause. So I'm pausing the video right now.